Okay, today we're going to learn about natural logarithms. So let's just do a little quick review. A common logarithm is when the base is 10, and you will see this the most throughout your high school career. You'll have something like log and then the number. Since there is nothing written here, it's a common log. We understand it to be base 10. And a common log problem is asking you to solve 10 to what power will get me 1,000? And the answer is 3. We're going to move on today to natural logarithms. Natural logarithms has a base of e, which we'll talk about in just a minute, and it's written on your calculator as ln. And we'll show you where that key is. But I want to take 1 second to go aside, and I want to talk about, look at my lovely little decoration here, earthquakes. You've heard earthquakes referred to as the Richter scale. An earthquake was a 6.1 on the Richter scale. Or scientists are turning to a newer scale, the MMS scale, which I'm not really that familiar with, so I'm going to keep to the Richter scale and just tell you how that's used. So we're going to go to a cool little website, and this website is, I know you can't see it up here, but it's earthquake.usgs.gov, and it keeps track of all the earthquakes that are happening in the world. And right now, it is showing you what I have up here, all the earthquakes that happened in the last 7 days that have registered at least 2.5 or above. And you can just click on the little buttons and you can see where the earthquakes have been. And you can see that there is this one right here that I have pre-clicked, and that was the biggest one that's happened in the past 7 days. And it actually was a 7.5 on the Richter scale. It was in Alaska on January 5th. Longitude and latitude are listed here, and then this 9.8 is the depth of the earthquake. And you can see, even right over here, let's see what that one was that I clicked on. Well, that's in Tennessee. Wow, there was an earthquake in Tennessee. It was 2.6. It had depth of 6.3. So again, it's a cool little website. You can go around, you can play with it. But let's bring that back. And what does it all mean? Well, that Alaskan earthquake was 7.5. That's what it means, 10 to the 7.5. That's how powerful that earthquake was. And the Tennessee earthquake, just to make it easy, we're going to say it was 2.5. I know it was 2.6, but just to make this an easy problem, let's say it was 2.5. Now it's easy to compare the earthquakes to each other, because I want to see how much more powerful the Alaska quake was than the Tennessee quake. I know I have to divide, and when I divide now, I subtract the exponents. So 7.5 minus 2.5 gets me 5. So this earthquake of Alaska was 5 times as big as the Tennessee earthquake. And that's one reason why we still use logarithms, because it's much easier to talk about in terms of the exponents than it is to have these huge numbers. All right, so let's get on to E. There it is. There is E. It's an irrational number, just like pi is an irrational number. Now, it's irrational because it goes on forever and ever, and the pattern actually changes. So here it's 2.71828188. You think that's the pattern over and over again? No, it's not. It changes. So pi is 3.14, and for the most part, E is approximately, we'll always use 2.71. Now, E is very, very important in science as well as financial institutions. I'm not going to give you a history or a lesson on how E is used in the banking industry, but let me tell you, It's used daily. In fact, it's used every second. We're just going to learn that E exists in Algebra 2. It was founded by Jacob Bernoulli. He is French. And while some people say that John Napier invented it, he kind of stumbled onto it when he was doing his logarithms, but he overpassed it. He looked at it and he kind of kept moving. It was really this guy, Jacob, who really did the work with it. And then Euler took it further. And that's why people think it's called the letter E, because Euler, he did a lot of work with it. But it was actually Bernoulli who founded it. And this is what E is. It's the summation of 1 plus 1 divided by 1 plus 1 divided by 1 times 2. You remember what these are called? These are called factorials. And if we had to write a summation down, here's the summation. 1 to infinity, 1 over factorial plus 1. And if I went to my calculator real quick, look at my handy dandy new fancy calculator here, and I just did it out real quick, you can see x1, and I'm going to put the number 20 up here just because I have to put a number. 1 divided by x factorial plus 1. Now I have to, in my little thing here, I have to convert this number to a decimal, and voila, there it is, 2.71828. All right. Now, is dealing with a natural logarithm any different than dealing with a common logarithm? Nope. The bases are just different. So for example, if we wanted you to do this, you can do it two ways. You can do it on the calculator. So here's my old calculator. And I can come down here, and let me make it bigger so you can see it. And it's not asking me to take the log, it's asking me, if you remember, to anti-log. So, second function, log, gets me the anti-log of 0.6884. And there's my answer, and I'll round it to the nearest hundredth just to make life easier. Right? If we go back to this way, we know that the base is 10. So the base is 10. The exponent is 0.6884. And my answer is x. So there it is. I could write it out by hand, or I could have done anti-log on the calculator. All right, now for this one, if we look down here, here's our log key, and right below it is our natural logarithm key, and it just means base E. This is base E. E to the 0.6884 will get me my power of x. I can type it in the long way on the calculator, and E is right there above the division sign. Second function, E to the 6884. Whoops, and I can find out my answer is 1.99 roughly. Or I can just anti-log, because if I press anti-natural logarithm, the E comes up. 0.6884. All right. Oh, and by the way, let me just give you another little fact about natural logarithm. We're sitting here saying natural logarithm. You would think that if we looked on the calculator, it would say NL, but it doesn't. our key is ln, logarithm natural. And there's a simple reason why. Bernoulli was French. And for those of you who take French, you know that when you use an adjective to describe something, it comes after the noun. Please don't make me do my French fake accent. Logarithm naturel. Okay, so let's just practice a few problems real quick. We'll just use natural logarithm. So they want us to express the natural logarithm of n in terms of x, y, and z. Hey, the log rules still apply. If I'm going to take the natural logarithm of n, then I have to take the natural logarithm of xy over z. What I do to one side, I have to do the other. However, we have to expand this because John Napier and now Jacob Bernoulli, they don't believe in multiplication or division. So by expanding, the natural logarithm of x multiply turns into plus the natural logarithm of y, and the division turns into subtraction, natural logarithm of z. There you go. You expressed it in terms of natural logarithm of x, natural logarithm of y, natural logarithm of z. And the last problem. We're given a little clue here. Remember how I say this? Every time I see log 7.11, I replace it with a b. Okay, well, here is log of 7,110. Well, that's not quite 7.11, but it's 7.11 hidden. You see, I can take 7,110 and rewrite it as 7.11 times 1,000. All right. Now, this problem wants us to work in logs, not natural logarithms. And the regions will jump back and forth between logs and natural logarithms. You're going to have to pay attention and decide which one they want you to work with. So, if I'm rewriting this in logs, the natural logarithm of 7.11 times 1,000 has to be rewritten as the natural logarithm of 7.11 plus, did I just say natural logarithm? I'm sorry, the log of 7.11 plus the log of 1,000. Okay, here we got, look what we got. Every time I see a log of 7.11, I can replace it with a b. Woohoo! That gets replaced with a b. And the log of 1,000, well, that's a common log with base 10. I know what that is. That's what we started the whole lesson with. That's 3. And there's my answer. Have a good night.